Now let's take this problem of problem number 49 of your textbook. It says that two masses M1 and M2 are connected by a spring of spring constant K and are placed on a frictionless surface. There is no friction. Initially, the string is stretched by a distance x naught when the system is released from rest. So the initial condition is this is a surface and there are two blocks. They are M1 and M2. They are connected by a spring. And it says initially, let's say this is the initial length of the neutral length of the spring. It is stretched by a distance of x naught. Since it is initially stretched, obviously, spring, right at the beginning, spring has a stored potential energy, right? The spring has a stored potential energy. The question is, when the distance moved by the two masses, when they again come to rest. Now, it is initially stretched. Now, if you suddenly release the spring, or rather suddenly release them, then what will happen? M1, the spring will compress, and let us say M1 comes here. And let us say M2 comes here. Now the point is, this is the first bounce. This is the first bounce. This is the, and let us say this distance is x1, and let us say this distance is x2. This is the first bounce, the spring. Of course, our common sense says the spring will now be compressed. This is the first bounce when both of them come closer to each other. In fact, the point is, at this time, the spring length is not the neutral length. It will be less than the neutral length. Because of the potential energy release, it will come smaller. Anyway, at this point, let us say this is the distance traveled x1, this is the distance traveled x2. We need to find out what are the values of x1 and x2. Now, let us say, now the body M1 has moved by M1 x1, has moved by the distance x1, and its mass was M1, right? Suppose this happened during a small time delta t. Suppose that is where you need to start. Suppose the spring contracts within a time of t. And in delta t time, M1 has moved by a distance x1. So what is the velocity of M1? Velocity of M1 is equal to x1 by delta t. And what is the velocity of M2? If we write it, V2 is equal to x2 by delta t. Now what is the momentum of x1? M1? M1 multiplied by V1. Momentum of M2 is N2 multiplied by V. Now, so from the theory of conservation of momentum, we write from the theory of conservation of momentum, what we can write? We write m1 x1 by del t equal to m2 x2 by. From here we get a simple relation m1 x1 is equal to x2. This is the relation that we need later on. So let us give it a name 1. Now, spring has, what is the final compression of the spring? Final compression of the spring, compression of the spring is, it is compressed by x1, also it is compressed by x2, and it was already stretched by x0. So, and the final condition, the spring is compressed by x1 plus x2 minus x3. And so final potential energy of spring is equal to half k into x1 plus x2 minus x0 whole square. And what was the initial potential energy of the spring? All potential energy of the spring was equal to half k x. Now this energy and this energy has to same because there is no other external force. So we can, since there is no external force, there is no other external force, this half k x square, half k x0 square will be equal to x0 will be equal to x1 plus x2 minus x0. From here we get x0 square is equal to x1 plus x2 minus x0. From here we get x0 is equal to x1 plus x2 minus x0. From here we get x1 plus x2 is equal to 2x0. Let us say this is equation number 2. Then from equation number 1 and 2, we can easily find out the values of x1 and x2. So we write from equation 1, we get m1 x1 is equal to m2 by m1 multiplied by x2. We get it from equation 1. Now, from putting this value in equation 2, From equation 2, we get x1, we value put from here, m2 by m1 x2 plus x2 is equal to 2x0. From here, we get m1 plus m1 plus, from here we get equal to 2x0. From here we get m1 on the left hand side, we get m1. This is m2 x2 plus m1 x2 is equal to 2x0. From here, we get x2 is equal to 2 m1 x0 divided by m1 plus m2. So, what is the value of x1? x1 is equal to m2 by m1 x2 is equal to m2 by m1 x2. We have got m1 x0 divided by m1 plus m2. This is equal to this m1 and m1 gets cancelled. So this is equal to m2 x0 divided by plus m2. So these are the two values. This is the x2 by which, this is the x1 by which mass 1 will move, and this is x2 by which mass 2 will move. Okay. Now, next we shall go to the next question.